The third planet from the Sun is the most special planet of them all. It's, of course, the planet we call home, and the planet we know the most about. But do we know everything about the blue marble that we call home? Earth is, of course, a one-of-a-kind planet. It's the only place in the solar system that we know has life, and the only place in the universe which we know has life. A special world in a special solar system needs explaining. How did we all come to be here? How was planet Earth formed? How did planet Earth come to the way it is today? These are important questions that need to be answered. As I said, Earth is the third planet from the Sun. It orbits 150 million kilometers from the Sun and takes 365.25 days to complete a year. Now that 0.25 is important when it comes to leap years. 0.25 is of course a quarter, and that is why we have a leap year every 4 years. The Earth-Sun distance is 1 AU, which is 1 astronomical unit, and this is used a lot in rather large solar system distances. Earth has a rotation period of 23.93 hours, which is 23 hours and 56 minutes. Of course, us humans, we just round that up to 24 hours. This rotation is, of course, way faster than the two planets we discussed in the last two videos. This is a bit more typical for a planet to have a rotation period like Earth's. Earth is 12,742 kilometers across on average. That's its diameter. It's also the densest planet in the whole solar system, at a density of 5.51 grams per centimeter cubed. The reason for this is because the Earth has quite a strong gravity for its size. It has a stronger gravity than the planet Uranus. This gravity that Earth has causes a sort of gravitational compression effect, and this causes the planet's density to rise and rise, and it's become even higher now than that of Mercury's. From what we can tell, the Earth is made up of several layers. It obviously has the crust on the outside, which is obviously the coolest part of the planet. Deeper down, the temperature rises down into the mantle, which is a layer of a sort of half solid, half liquid rock. Deeper down still is a liquid outer core, and the reason we know it's liquid is the different types of waves that earthquakes emit. When they happen, a specific type of the waves that earthquakes emit don't make it all the way down to the other side of the planet, but the others do. And the reason is that this specific type of wave does not travel through liquids. So that then infers that the core of Earth, at least the outer part of it, is liquid, and now the pressure is likely very high in the core as well. So the core at the center is probably solid metal, like solid iron and nickel. And now the Earth's surface is divided up into tectonic plates, which was only really accepted as fact by the early 20th century, I think. Along the borders of the tectonic plates that make up the Earth's surface are where most of the volcanic activity and earthquake activity occur on Earth. And this is because the plates are rubbing against each other or colliding with one another or going apart. There's several different types of plate boundaries and they cause activity at the surface. Earth has about 1,500 volcanoes on it. It's one of the few bodies in the solar system that still has volcanic activity. Most bodies in the solar system have cooled far too much to have any sort of volcanism on them. But that is because the Earth is big, and so it's losing its heat to space a lot slower than, say, Mars or Mercury. In the early history of Earth, it was inhospitable to life. It was bombarded by asteroids a lot in its early history. Its atmosphere was thick with toxic gases like ammonia, and it just could not be suitable for life on the surface. And its oceans were acidic, but bacteria started to convert the ammonia and the carbon dioxide into oxygen and nitrogen, and over many millions and millions of years it transformed Earth's atmosphere into the atmosphere that we see today. Earth is of course the only planet and only body that we know of where we have found liquid water. And liquid water is all over the planet, in its oceans, in its lakes, and its rivers. And the question is, where's all this come from? There is so much water that something very significant must have happened for Earth to get all this. There's plenty of water in the solar system, but none of it comes out as liquid. It's very likely that some moons in the outer solar system have oceans of liquid water also, but we haven't seen them. So where did all of it come from? When we first started theorizing where Earth's water came from, we looked to comets. And now comets are asteroids that are made up of mostly ice. So when they come close to the sun, they give off a tail because all the water is being blown off it by the solar wind and being evaporated. Key thing about the water on Earth is that it has almost the exact same deuterium to hydrogen ratio almost everywhere you go. Now, deuterium is an isotope of hydrogen that can also make its own kind of water. Correct me if I'm wrong, but I think it's called heavy water. It easily mixes in with regular water, and the ratio is tiny on Earth, but it is a key identifier of where water would come from in the solar system. If something has a different deuterium to hydrogen ratio, then the water cannot have come from that. Now, what we found in comets is that the deuterium to hydrogen ratio is significantly higher in comets in general than Earth. This threw a big spanner in the works to what gave Earth its water that we see today. But then we looked to asteroids, and the general trend that we're seeing in asteroids is that the deuterium to hydrogen ratio has been a lot lower and more similar to Earth's deuterium to hydrogen ratio in water. And so now we think that our water has more likely come from asteroids rather than comets in the solar system, solely due to this deuterium to hydrogen ratio difference. As said before, our atmosphere is made of mostly of nitrogen and oxygen. It's 78% nitrogen and 21% oxygen, with just under 1% of argon and some other trace elements. The average temperature on Earth is about 14 degrees Celsius. The highest temperature ever recorded was 56.7 degrees in Death Valley, California, and the coldest temperature ever recorded was minus 89 degrees Celsius in Antarctica. There's a big range of temperatures on this planet. Earth has its own magnetosphere, and this basically protects us from the solar wind. Basically what it does is that it absorbs the charged particles from the sun into like a tail that goes a long way behind the Earth. And these magnetic field lines storing the energy, they often snap together. That causes a rush of charged particles to go down through the field lines towards the poles on Earth, because the poles are where the magnetic field is generated on Earth. And the charged particles hitting the Earth's atmosphere at the poles is what the aurora is. These are particles getting excited to different energy levels. It is an absolute wonder, the aurora, and I hope to see it one day myself. Now, the fact that we exist on this planet, the fact that life exists on this planet, is truly a miracle of nature. The fact that we are in the right place in the solar system, the right temperature, the right atmospheric pressure, the right ingredients, is just a miracle. We haven't found any other planet that have life on them yet. And so for all we know, we could be alone in the universe. But if we're alone or not, Earth is still incredibly special in the universe. Wherever life exists in the universe, it is a special, special place. We should take care of everything that is on this planet and never take it for granted, because this is our only home and we're not moving anywhere else. When people ask me what is the meaning of life, I answer with this: life is the way that the universe expresses itself. Without life, the universe cannot be seen through conscious eyes. Life is the way that the universe has meaning. And the Earth means a big, big amount indeed to the universe, whether we're alone on this pale blue marble or not. Thank you so much, guys, for watching this video. I'm a bit less expertise on the Earth subject than the other planets, but I did as best as I could, and I hope you enjoyed this video. We'll be back next time with the red planet. I'll see you all then. Goodbye.